And we're live. Hello, everybody. Welcome to this edition of the SwiftUI Animation Challenge Solutions. I'm here with Amos. So, Amos, you can say hi.
Hello.
Very good. We're just figuring out the last bits here, and we will start in a second. I'm just going to share the link to the live stream on Twitter, because we want to show people that we are live, so that maybe one or two people will watch and join us.
Yeah. I can retweet it as well.
Yeah, give me a second. Yeah, this one. Right, I just tweeted it. So
let me refresh and see.
Yeah. All right.
Yeah, I can see it.
Nice. Then I just need to share my screen now. All right. I will share this one. This already has one solution open. But we want to start off by showing the video first. So yeah, I'll show this in a second. Yeah, good. So we in total we received 5 submissions for this one, which we were very happy with, because I think this was the toughest one, right?
Yeah, it's really tough. I can see.
Yeah, so like we got the inspiration from this one. I think we mentioned this even from Duolingo, and it looks rather simple, but like there's a lot of gotchas there. So this is the one that this is the challenge video basically that we shared, right?
Yeah.
And I can already say, like, our solution that we will show later on is a little bit more sophisticated, but like overall it's basically this, just with a little bit of added fun basically to it. But we can also already say that it was really impressive, like the solutions we got. They, like, I think not only did they look very nice, but it was again the case that people have gone, or like have been very creative, right?
Yeah, they even went beyond expectation. Like I saw 2 of them, the way they approached it was totally different.
Yeah, absolutely. And like I might say that I even liked some of the solutions more than our solution.
Yeah,
so yeah, like I think they've done a really great job.
Yeah,
and I already see
so
Mert,
nice.
Mert's in the chat, so that's very nice.
Oh,
Hope you
good.
enjoy the
It's
stream.
good that
Hey, Flo as
he's
well.
here. Yeah. Okay.
Cool that you check by. So yeah, I think like so we've seen like the challenge, right? So this is how it looked. So I think we can get started, right? Or is there anything you wanna add there, Amos?
I don't need to add anything. We can just get started. From
Right.
the one who just submitted first. So
Yes.
I think
so. The first submission was by. Can you say the name?
Let me check. Yes, Prismo Kuvan.
Yes,
No,
exactly.
Primos Kuvan also. Yeah.
Maybe, yes. We're not
Yeah.
sure yet, but
Oh,
but yeah,
okay.
like that was the first submission.
Yeah.
So I have that already opened, but there's also a demo video attached, which I always love. Like it's always great if there's a video showing the animation as well, because it's always good to have a first look at it, right? So that's a great thing. So if you have a look at it, you can already see. So yeah, it looks very nice, very close to the one that we created, I think, right?
Yeah, it's really close. Yeah.
It has this nice background here with a little bit reduced opacity, and like this this flame going up here, which is also a very nice effect. So yeah, I think like it looks great. It looks really close to the solution we had. So I think we should just dive in, right?
Yeah, let's dive in.
All right. So let's make this full screen and have a look. So it's a shared one. So that means basically there's only an iOS solution. All right. But like we can see here, okay, so the baseline is the Fire view. So we can directly go here. Can probably close this. I hope it's readable. Like I feel like it's large enough for the stream.
Yeah, I can read it. Yeah.
Good, perfect. All right. So what did Primoz? Maybe it's correct pronunciation. Always happy to be corrected here. So what did they do? So there's a few constants defined here and the state variables. All right. So let's see. By the way, it's the first stream where we can officially use Xcode 14 because it's now in stable release, right? So that's very good. All right, so we can already see like the body has the frame here. I'm not sure why he needs that, but yeah, like that's the initializer at least. We have okay, so it's measuring the size. Interesting. Okay. So we have this. It's a Z stack basically. We have the first fire layer, and the minifier, second and third fire layer. So it's 3 layers. Nice. And then we have the fire animation view. Okay. Which has a few parameters. So maybe we should okay, so there's multiple things we can check here. We should probably go like step by step. The fire animation view. So this looks like this. It doesn't have a preview. But what does it use? So one interesting thing is that they decided to create initializers, and I don't think we need this, right? Because for structs, you basically get the default initializer for free, right? So if we were to remove this one, then you basically get the initializer for free that says all the uninitialized properties should be initialized, and you get this initializer for free. So I think that's not necessary. But nevertheless, at the root of the body here, there's a fire shape with a defined width, and there it has some spike positions, X and Y, and a radius. Okay. It's filled with the fire color and with the firing of a timer, which fires every 150 milliseconds. It updates the view. And for the update, basically it says the spike position is updated. So if we take a look at the fire shape now, there we should see the basically the heavy lifting that's going on, right?
Yeah.
Thanks, Flo, for pointing out that it's readable. It's very good. Hope that, like, if there's anything that cannot be seen very well, or that's not shown, then please let us know. All right, Mert says Xcode 14 creates inits automatically. I do look for the reason to create init in everything. Yeah, so like it can automatically create an initializer, but a struct automatically has one, right? So for example, we can see it here, right? The fire shape is also a struct. It has these properties, and there's no initializer defined, but it, like a struct automatically has a member-wise initializer, which a class, basically, by the way, does not have, right? So that's one of the differences between structs and classes, that classes don't get member-wise initializers. So, I mean, what you could automatically generate the initializer, that's fine, but you don't need it, right? So it's automatically there for you in a struct. That's what I mean. All right. And then we get here the animatable pair. Cool. Nice. Do you know what the animatable pair does, Amos?
Yeah, I know about that.
Can you quickly explain it?
So it allows you to just animate multiple properties of the same view. Like here we have the shape layer, so it will allow you just to animate multiple properties of the layer.
Yeah, exactly. And like the nice thing is that like I only think it's really necessary when you create shapes and you want to animate parts of the shape, right?
Yeah, so by default the shape is not animatable. So if you use the animatable data, then you are just making the unanimatable become animatable. Yeah.
Yeah, and I learned about this from the SwiftUI lab. I think he's called Javier, and he has amazing tutorials on animations. And like there was this really cool like circle that turned into a shape with multiple corners, and like you can increase it. And like he showed where animatable pair is really helpful. So it's a very good resource, I feel like.
I have to check it. Yeah, I haven't seen that. I'll check it.
Yeah, it's I can highly recommend it. So yeah, like this is basically a way to animate the path here, or to animate certain points in the path, because that's basically what the contributor here is doing. So it uses the spike positions. Hello, no worry that you're late. We're just going through the first solution. So cool that you're here. We're always happy to see people joining this stream. All right, so what this does is it creates a path. It defines an offset, which is 1/15 of the height of this object. And then the first point goes to the middle, basically, with a slight offset. And the second point is then slightly to the right or left, depending on the value of the spike position, and to the up or like to the top or bottom of the Y point. And we have a third point as well, which is again slightly offset. So we're adding an arc where the center is the first point. That's in the middle, right? The radius is half the width of the object. We have start and end angle and a counterclockwise rotation. And then we basically add two curves to control points. The first control point is to the left, and the second one is to the right. Yeah, that's basically it, right?
Yeah.
So that's the baseline shape. Yeah. Okay, so Matt says that like if you animate X and Y coordinates of the fire spikes with the CG point, It just jumps over. It doesn't get animated. I feel like that has probably to do with the animatable pair thing, because like you manually have to define like which values are really animatable. So by doing this, you basically tell SwiftUI, if you go from one point to the other, that it shouldn't go straight to that point, but it should basically interpolate that, right? So it says, okay, so I have like 1 second, right? And I'm redrawing at 60 frames per second, for example. So at every frame that is shown, it will calculate like, okay, so I'm going 1/60th of the way. And then at the next frame, again, 1/60th, and one again. And it only knows that it should interpolate that if it's part of the animatable data. And I think like simply having the CG point there is probably not enough. So I'm not an expert in this, but I feel like it's, at least if you want to make sure that it works, you need to have primitive values, like something like a CG floats or numbers, basically, right? And for CG points, it doesn't work. I think you should be able to get it working with CG point as well. You probably have to conform to a certain protocol, but I can't remember which one it is. So if you want to make sure that it works, then you should probably take this one. Yeah. So you mean CG point with the animatable does the same thing in jumping, right? Okay, but yeah, we can talk about this more. But yeah, just like the shape, it's basically just drawing the shape, right? So that's what this does.
Drawing.
Yeah. And yes, Matt, like if you want to make sure that it's working, then I think primitive types are the way to go, because I think this is a limitation of SwiftUI, that it doesn't allow you to animate more complex values out of the box. All right, then we have some some color definitions, and we have this measure size modifier, which is interesting. So it basically just says, okay, we have the content, and in the background we have the geometry reader that is defining the size. So it's basically an invisible thing, right? Because we have the color clear, and on appear it says it gives the size of the current view, right?
Yeah.
Okay. And where does he use this? Here, right? Okay.
Oh yeah.
Interesting, but I'm not sure why this is needed. What do you think? Like, why is this person using the geometry reader in this case?
For me, I don't think it will just do anything. Can you try to just remove that, and then let's see what it does?
Which one do you mean? Like this one? This?
Yeah.
Well, that's underwhelming.
It's
probably just an error.
There's something going on somewhere.
Okay, so because it's an optional, right? The frame. But I think I don't think that you need to do this with the size here, because you can. I mean, we will probably see it later on how to properly use it, and we can also show our code, right? But yeah, this is. I mean, this feels like a redundancy basically, because SwiftUI will automatically assign the frame the correct, I mean, correct is relative, but like a proper size for it, right? I mean, there's a certain algorithm going on basically, right, that determines the size of a view, and it's not that complicated. Like I mean, there's a very good good talk at, I can't remember which one it is. Okay, I can't remember the name, at WWDC. I think it was last year, about the entire layout system of SwiftUI and how it determines like how large views should be. And also the book, I think it's called Pro SwiftUI by Paul Hudson, also goes into that. But there's a very distinct algorithm to determine the size of views. That it has to do with suggesting a certain size to children, and then the children can basically determine their own size. But I mean, like with this entire algorithm happening, I don't think it's necessary to really go into the frames there, but you can basically just set a width, or it will automatically expand and take a width on its own. All right, but let's just have a look at the different layers here we have, right? So we have the first file layer, and we can maybe comment out to see which one that is. All right, so this is the first layer. So how does it look? It says, okay, so we have the certain frame or the measure view size, tertiary color, and a width, and some offset. All right. So what is the minifier then?
I think it's the one in front.
Oh, yeah.
Oh no,
That makes sense, right?
it's the one
It's
behind.
the one that's moving upwards,
It's just moving,
which is probably just the offset, right? Yeah, I mean, the offset is animating here. With yeah, like it's basically a timer that's firing.
You see animating the X offset as well. Oh yeah, that's why it is just moving just like that. Yeah, I thought it's only Y. Yeah,
and even the rotation a little bit, right? So the rotation is a little bit animating here as well.
Yeah.
All right, that looks cool. I mean, it's a cool, like it's one of those details I really like, when like it's not the main view that is in plain sight, but it's just something in the background that's happening. But it's nice that it's like it has seen some love with the rotation effect, and like a little bit more, like not only like animating it from the bottom up and that's it, but like having it like rotate a little bit.
Can you offset the rotation and let's see what it does? Like placing the offset above the rotation.
Oh yeah. That looks fancy.
Yeah. Okay.
Yeah, like it's basically just giving it a slight animation, right? That it's
like it just
animating slightly.
Changes the path slightly.
Yeah, and it's also randomized, right? You can see here.
Yeah.
That it gives it a random degree, like from -10 to 10. So nice. I like this. It's a nice effect for sure. All right, this is the second file layer. And we also have the third one. That's probably one of the, oh yeah, nice. So the third one is the little yellow one, right?
Yeah.
And the second one is this one, right? And what you can see when it appears, it's just animating, like it's basically this half circle at the beginning, and then it's animating just this point, like in random values, right? So it's a very simple thing basically, but like to have it showing correctly just requires a little bit of time and playing around. And I know because we've tried as well, and it also took us a bit of time to get it like in a decent spot at least. So we get this. All right, so we have all these layers here, and let's put it together again. So yeah, like I think what the cool thing is that like the background here is basically also just this layer here, which has this nice effect that it feels like it's like some form of shadow maybe that's just happening behind it, but it's freely animating as well. So this is a very cool effect. So yeah, I think that's basically all that is about that one, right? So it's basically just drawing a certain shape, and then animating one of the points in the shape, and then just replicating this into different form factors, different sizes, and then adding some more animation with the small one, right? Anything that stood out to you aside from that?
Yeah, it's just interesting, like seeing it at first. I didn't know like he was using Spring animation, but if you go to the Fire animation view, and then you pass some parameters to the Spring, then it also creates some interesting effect. So
you mean here?
yeah. For example, you can just change that to an interpolating Spring, and then you give it a stiffness of maybe 170 and a damping of 5. So it creates something like it makes it look as if it is windy, like everything is so fast, and then yeah.
Oh, very nice.
Yeah. It
That
looks
looks
really
really
nice,
cool.
and that's it's cool.
Well, that's something we can always encourage people to do, right? To just like if you have the baseline setting, right? So if you have the basic animation done, then it's always nice to just play around with different types of easings,
different
right?
effects.
Yeah, exactly. Try a spring, try different easings, try interactive spring, try interpolating spring, try different parameters, right? Because like you can always create new effects and like new things and new impressions around an animation by simply just changing those values, and it's a lot of fun to play around with that, I feel like, right? Yeah. So yeah, great recommendation from you. Really like this, and I think it's a very very good solution because it's very close to the one that, like, basically to the challenge we set, right? And it's also the first one, so I mean, no participant would of course have a look at other solutions before submitting their own, but the first one at least for sure can't do it. So I think like that always deserves some credit at least, right?
Really well done. Cool.
All right, so very good job at Primoz. Yeah. All right. The second solution comes by good friend of the show, Matt. I think he's one of the only ones that basically submitted one for every.
I think for every challenge he has submitted one. Yeah.
Yes, right. Yeah.
And then he has been participating in all the live stream as well.
Yeah, that's very cool.
Nice.
All right, so I'm just opening things up here. Give me a second, because I always have to check out everything. Alrighty. So you should be able to see it, right? Yep, this looks good.
Yes.
By the way, we're again using StreamYard for streaming, which you can see because it's very large in the top right-hand corner. But I mean, it's cool because like it's a very very nice tool, I feel like. It really helps us to get this done because some people were there for the first edition of our live stream, right? And I mean, it's on YouTube, so you can watch it. But it's basically it was like a very chaotic stream. We were having heavy technical difficulties. Basically, nothing was working, and we were trying to figure it out for like 45 minutes. And people were giving us advice, and it was very nice. But yeah, it took quite some time for us to figure out how to do it right. So it's a very cool tool that really helped us make this happen without much effort. So very cool. And it's okay that we also promote the tool by doing this. All right, so let's have a look at Matt's app. He's using in the content view, nice, which has the animation flame view. Cool. So yeah, there is something going on here. That's good. Let's continue the preview. We already see it. Nice. Okay, so what do you think on first sight? What do you think of this solution, Amos?
I like the randomness of the animation, and then it looks like all the points are not moving in one direction, so it makes it look really interesting. Yeah.
Yes. I think like it's the two parts are definitely animating like independently of each other, right? So each have their own set of randomness.
Yeah. It makes it look really interesting. I like it.
Yeah, it looks a little bit different. I think like this, like in the previous one, this was a perfect circle, and here it isn't. But I mean, of course, that's everybody can like this. This is some fine tuning, and
it still resembles fire. So I think that is the main thing. It resembles fire.
Yeah,
so
exactly. So there's different ways to do it. Yes. Yeah. And by the way, thanks Gordon for pointing out that the first stream was a great joy. We also feel like it, but it was also very nerve-wracking for us.
True.
So yes, okay. So let's go through it. Like one thing I really love is naming. I mean, if you have the chance of naming a variable wiggle factor 1, I mean that's just excellent, right? I love this.
Yeah.
Wiggle factor 1 and wiggle factor 2. That's great. All right. So basically, we have two different states. And if you have a look here, we can see that these are sizes. So this is the randomness factor already here, right? Because like we have the two flames, and like if we comment out this one, we will see, yeah, there's only the orange one. And if we comment out the orange one, we only get the yellow one. It's also using a geometry reader. I feel like this is a better usage of it because you basically just embed your view, in this case, the Z stack, inside the geometry reader. And then you have access to the size of the container. And Matt makes use of this, right? So he basically says that the yellow flame only takes up 40% of the width and 40% of the height of the entire view, right? And the rest is basically taking up the entire view. It also it just has some padding. So yeah, I think it's a very like it's a simple yet powerful usage of the geometry reader here.
Yeah. Cool.
All right, and then he even mentioned that yeah, like the yellow flame is offset a little bit. And it's just a magic number. So he basically he played around with and found a good offset, which I think is totally fine, right? I mean,
yeah, it's true.
It's
I
of course
play
always
around
great.
that as well.
Yeah, it's always great if you have like a very logical thing how to come to a certain value, but sometimes it's just just play around, like try different values, and just you will find one that just fits your needs. So yeah. All right. So aside from that, like I feel like oh yeah. So what we have here is then like on a peer we said step in a flame, step out of flame. So basically just say okay, we assign a random value to it, right? To the wiggle factors. I can't stop saying these names. So we assign different values to the like randomized values to the wiggle factors. And then, like we always say, okay, so we wait for a delay value, which is again randomized. And after that, we basically call the function again, right? So this is the randomness. Like it's nice because not only randomly animates the top point here to a certain point, but it also has some randomness to the waiting time in between animations. So that's a very cool idea as well. I'm not even sure if we are doing this, to be honest. We have to see. All right, so I think that's the baseline here. So let's have a look at how Matt implemented the flame. All right, so we have the flame, which is a shape again. We have the wiggle factor X and the wiggle factor Y. Nice. And again, we can see that, I mean, this could also be a CG size, right? But I would assume that he ran into the same problems as we did and Mert, as you did as well, because he also splits this up, right? I mean, it's basically just the X and Y value of the CG size, but this probably won't animate nicely. So he needs to split this up into separate values. And with that, he has this animatable pair that then can really animate in the shape, right?
Yeah.
Yes. So what he defines a few values here, like there's certain amounts here, and so he defines the top point of the flame, which is at different positions depending on the wiggle factors. And yeah, basically what it does is it has the path, right? It moves it to the bottom first. So the first point here is the bottom point. And then it adds some curves. So he basically first doing the semicircle at the bottom, then it moves to the top, and then I think the right point of the circle, and then to the this curve to the bottom again, or around the bottom, back to the starting point. So yeah, I think it's I'm impressed with how easy and short the code is, basically, because
yeah, I wanted to say something about that. Like, it looks really simple. Like, even here, he defined all the control points, which make it easy to just understand, and it's just very simple solution and easy to understand.
Yeah, that's a good point. Like the easy to understand that you mentioned, right? Because it's very easy to just follow, right? We have the flame view. This has two flames, right? It animates these two values. I don't want to say the name again. And then it just has this path that defines a few values and then draws the path, right? It's very easy, straightforward, very well written, so it's easy to follow. I think you hit a great point there. Yeah, really good. So yeah, I don't think there's much to say about this one, right? It's a very cool solution. It's very simple, very well executed. I'm impressed with the simplicity of this one.
Cool.
Yeah. Anything else you have to, or you wanna add to that while I will prepare the next solution?
He also defined all the animations, like each part as well, which I just really like. So you are just talking about simplicity, so it also comes in that same way, like defining each part of the animation.
Yeah, very true. It's also very good, right, to have these clear definitions of these states. Nice. All right. As we can see, the next submission is by Mert, who's also in the chat. So we can't wait to see it. I mean, we had a look before, but of course, it's still nice to have a look then. Alrighty. So we have a Swift package again, right? I don't think he added a video. I don't think so. But we can just have a look, right?
You can just run it here and let's see.
Oh, I'm using an iPad here. Let's just go for the 14 Pro. Tap to start. Nice animation here. I mean, how cool does that look?
You went a little bit extra.
Oh yeah.
Cool. Now it starts.
Nice. All right, he mentioned that he added a description on the pull request, so let's have a look at that first. And he probably added. Oh yeah, he has the screen recording here. Nice. I mean, we have looked at it now, so I think we don't have to look at the video. But yeah, what does he say? So there's another fun challenge. Thank you. It's always fun. Okay, I've added a few scene before the actual file to achieve that. Create random CG points in an array with fixed started endpoints. That's cool, right? Random points is nice. Create a fuse view and added 3 circles in it. There's a main circle with a contrasting circle in it. 2 other are mimics the trail of the main circle with different scaling and synchronized ease and out. Oh, nice. Motion of the fuse view according to randomly generated path achieved with a recursive function. Oh, wow. It rotates the fuse by calculating slope of the line it will go through. Then fuse views coordinate are animated to end the CG point of the line. And then the recursive when it ends, basically, it disappears and the fire animation will appear. To achieve the fire animation, he created custom reusable flame shape. Nice. I think that's what the other people have done as well with the curved lines. And animated its middle points with animation pairs. Nice. It uses a time publisher and on receive, so it uses a timer. Okay, we've also seen this. Yeah, nice. And basically 3 reusable views arranged by rotation and positioning to achieve a similar view to the requested animation. Nice. So yeah, like a lot of thought went into this. And I mean, you can already see that, like the
even in the beginning.
Yeah, like if you it looks so cool. Like this is just like moving to different points here. Like I think it's really nice. I really like it. Right. Yeah. Very nice. So we can I could look at this like the entire day. And yeah, like one person in the chat also points out like how the flame bends is really cool, right? Like this effect, right? Like it's not only like a static point that is moving from one point to the other, but and that it looks also very, very nice. I mean, I'm not sure if I should say it looks realistic, but it has at least a very nice touch, and I think like it looks, in my opinion, it looks better than the regular just like animating a single point, right?
Yeah.
All right. So what should we look at first? I think it probably makes sense that we should look at the fuse view, which is a very hard to pronounce name. That's maybe my only criticism here, Matt. It's a very hard to pronounce. But yeah, I think we should probably have a look at this one first, right? Because it will then show the fire view, which we can have a look at later, right?
Yeah. Okay.
What do you mean, Matt? Thank you. I just said it's a terrible name, and it's not a terrible name to pronounce. It's a great name, of course, because it makes sense, but still, it's hard to pronounce. So you should have we should maybe have like this as part of the challenge to make it easy for us in the live stream to basically read out everything. Right? That will get extra bonus points for the next challenge. All right. So how does the fuse view look? All right. So all right. Okay. So he said that we can uncomment. Oh yeah, he even said this. I mean, it's yeah. You mean this one? Uncommenting this, right? Yeah.
Okay. It shows the random path. Yeah.
Yeah, it shows a random path. So if we build this again, it will be random. Right.
I think you need to just start it again.
Oh, I can just see if I just update the preview, it will show different paths.
Yeah,
that's very cool. I have no idea how he does that. So we should definitely have a look at this. Like, what does the fuse path view look like? It's basically just, yeah, it's just moving, adding lines for the different elements, right?
Yeah.
The fuse segments. All right. It's very cool that you built this, by the way. It's very, 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 very good to understand what happens. So thank you for that. All right. So we had to look at wanted to have a look at the fuse view. All right. Well, that looks interesting. I have no idea what's going on there. All right. Okay, so these are just 3 circles. So these are the third. Okay. But where is the fuse thing happening? Let's see again. So the fuse view with the rotation effect. Okay. Okay. But so I'm still trying to wrap my head around this. Okay. Like, what am I missing here? So we have the path, right? At the view model. All right. Okay, so what's happening in the view model? Let's have a look there. We have the fuse segments, the gradient, okay. And then we have some published properties, offsets, visible text colors. All right. So we have the fuse segments here, and then they're generated. I think that's probably one of the interesting ones, right?
Yeah.
All right. So how does he do it? We just have random values for index in 0 to between 10 or 20 points. And then, oh wow, like that, like how did you come up with that one? I would assume that it's also like playing around.
Yeah.
Because if you start off and just type out things and come up with that by just knowing what's going on, then I have mad respect for you, man. I mean, I still have mad respect because it looks amazing, but yeah, like this is something that would take me quite some time to just like play around with and somehow find a good way there. But yeah, it would be interesting to know, like if you want to share this, then because like it's one of these interesting things of like this animation looks great, but like probably you didn't have the entire solution in your head from the beginning, but you played around with it, like, and
No.
you like while playing around, you got new ideas, you found better ways how to do things, right? So I think that this is one of the interesting thought processes where people go through by creating animations, because if you see the end result, you think, oh wow, like this is magic, right? Like no idea how he came to this conclusion. But it's most of the times it's just like you play around, you fix something else breaks, and you have to fix this again. So yeah. All right, he already shared that 0.05 is the offset to not make this some point. Okay, so it doesn't go off the screen. All right, so it's basically, it goes from slightly left of the screen, right, to nearly the right edge of the screen. And in between, it just says, okay, so it goes from, yeah, index. Okay. All right, so, well, but why do you do the index divided by 100 here and not here? So for the x value, you say index. All right, I'm not sure why this is, because you probably could also like leave out this part and just make it go from like the same as here. Okay, so just giving some variety. All right. Yeah, nice, makes sense. All right, but then you basically end up with always the same point, right? So the same point is always in the middle of X and at like the maximum of Y. All right, and if we have a look at it again, we should be able to see this. So it always ends up here, right? Or here? Here? I always forget, like, what is Y1? Is it at the top or is it at the bottom? It should be the bottom, right?
I'm not sure.
Yeah, me neither. All right, but yeah, like it's still like it's randomly generating the points, which is nice. All right, so we were here, so basically generating these fuse segments, and then we're animating this like where he's animating the view like along the path, basically, right?
Yeah.
Right, so all right. So it says if fuse segments.count is equal to index, and index is 0, then we say fuse.visible is false. So basically we hide the fuse thing. Otherwise we rotate the fuse view. Rotate fuse view. That's here. Okay, so it's rotated. Okay. And it's probably rotated along the, like that it's like, so this is basically the thing that's rotating here. It always has to be aligned to the path it's currently traveling at, right? I think that should be what is happening here, right? So it's always rotating to follow along the trajectory it's just going, which is like, that's some serious math going on there, right? Like I wouldn't have known how to do it. I wouldn't have known this. So, I mean, can be honest here. All right, and then it's basically animating linearly the offsets. Okay, nice. All right, it's setting the offset to the X and Y values. All right, that's cool. So it's basically the way to animate the shape, like through the different elements of the path. Nice.
Yeah.
I'm impressed with that. Right, it's a very cool thing, and also like you know how to do it, but I've always struggled with animating things, like animating views along a path, right? I mean, this is a different solution, I feel like, because it's also possible to animate things, for example, along a
You mean
curve,
circle up
right?
or gap? Yeah.
Because with this, you wouldn't be able to do this, right? Because you're just animating from a certain offset to another offset, right? And it's basically just animating the path in between, but it's a straight line. But like I think it's I don't know. Do you have a tutorial how to animate like an element along a curve as well? Do you have that, Amos?
Oh, for me, no. I don't have anything like that, like to
because
animate. But I think I saw one somewhere. I think SwiftUI Labs also. They have one tutorial about that.
Probably, yeah. Okay, nice. But yeah, like impressive. The fuse thing looks amazing. It's really cool. So let's have a look at the fire then. So we're seeing basically the same thing again, right? We're seeing
the same as the
X and Y.
other one.
We're seeing animatable data. Yep, makes sense. All right. We have the init one. Yeah. And then, so we have the path, right? This is, yeah. let's look at this. So we have the path that's moving to this point, which X and Y, all right, yeah, which is probably here, right? This is the initial one. And then it's adding curves with control points. Like I don't want to go through all the curves because it's a little bit hard to always explain, right? But yeah, like basically a bunch of curves. Like I was struggling with that a little bit in the beginning because like I feel like it's hard to always get like these curves correctly to move to the correct points. But I mean, like I thought that I needed like the quad curve drawing to make it look good. But I mean, here Matt proves that this is not necessary. So he does it only with drawing curves with control points,
Okay.
which I mean, like as was pointed out by the chat, looks very, very nice. So this bending effect is looking incredible, right? So yeah, what does the fire view look like? I mean, that's probably like the most common thing that others have done as well, right? It's a Z stack.
Yeah.
We have this 3 flame shapes. So the orange one, the yellow one, and the one with the slightly less opacity in the back, which is probably this one. Yeah, and then like we have the timer who's firing every 0.2 seconds and changing the positioning basically, right?
Yeah.
Yes. But yeah, like I said, like I think it was really impressive. Like especially the fuse one looks just amazing, and also the bending of the flame here is really nice.
I
what
like
do you think?
I like the bending as well, but the one thing I will also do differently is like just offset the directions. So maybe you have the bigger one moving on the left, then the one in front can also move on the right to make it more interesting.
Yeah,
but
I think
this also works
what,
really well. Yeah,
yeah,
as well.
that's what Matt did, right? Like the previous solution we saw, the random offsets for the different shapes or the different flame shapes.
Just like what Matt did. Yeah. And then maybe also like offsetting the delays as well, because they all animate at the same time.
Yeah, that was also a very nice touch.
Yeah.
So, but that's one thing I really like, right? That it's like this is with the fuse view and everything and the path. Like this is a very impressive solution, right? But still, other people also had great ideas how to do things differently, and they also created really nice effects, right? So, I really like this.
Yeah, like the chips bending, I didn't even know how to just get that. Like it's really impressive.
Yeah, and Matt, he's in the chat and he said that it's like to draw these controls. It's like making curves in Vectormator or other design tools. So it's easy for him to visualize this. Yeah, probably. Like it is. Like if you have experience with this, then it's great. Sure. Like I don't have any experience with this, so for me it's really hard to visualize this in my head. So I'm impressed with that. Like great job. But yeah, not everybody is having an easy time with this. I can say that. But yeah, like yeah, so it's a great solution. Let's look at it one more time because the animation looks so cool, right?
Yeah.
You could also play around with easing curves here, right? To not only make this a linear thing.
So he's using a linear. Yeah. If we can also play around with the other ones as well.
Yeah, that would also be fun, right? To just have this. Yeah, but yeah, like I said, I don't wanna criticize anything. Just like if you want to play around with it more, that's the things you could also do. But like we said, it's a very impressive solution. you manage to impress us every time you submit something. It's looking really great.
Yeah, he always adds something more, like goes extra mile to add great things.
Yeah, that's really
like
impressive.
it a lot. Nice.
Yeah, so great job. Yeah, nice. All right, let's have a look at the last iOS solution, which is by Gadirom. I have to quickly check it out.
Is it the one from Roman? I think it's also a Swift package.
Yeah,
I think
Roman.
Is the one.
Yeah. All right. Nice. All right. Oh yeah, that's one that's using metal. So
oh yeah, he also added some README also.
Yeah. All right. Cool. Here is my submission. I can make this bigger. Okay, so he wrote, here's his submission. Nice. He made it on iPad in Swift Playgrounds. That's amazing. Mad respect for that. It's not pure SwiftUI. It contains some metal code, but it's integrated in SwiftUI views. It uses a declarative approach for dispatching shaders. Nice. I will gladly have a look at this and probably understand nothing because I have no clue of metal. He uses his own open source package, Metal Builder, for this. Cool. So he has an open source package. Nice. We definitely will have a look at this. It's a wrapper that allows to manage metal objects in a functional manner, mimicking the SwiftUI. For example, buffers and textures are created using property wrappers like this. Oh, that's very nice. I mean, this is really cool, right? Because metal, like, while I understand nothing of it, I know it's like it's a very low level thing, and it's used in not only graphics, games, and also like ARKit textures. But like it's very cool if this is made easier to understand. And apparently, like with his open source package, Metal Builder, he probably achieved something like this. So we will see if we understand what he does, right?
Yeah.
So it's cool. Created like any other SwiftUI view, takes a result builder closure. Nice. Okay. Yeah, like we will have a look at this. I'm just reading the rest of the README. All right, yeah. So basically, you can hand down parameters, even as bindings, to make changes. All right, cool. So as he mentioned, this reduces the amount of metal code that should be written and makes it much more simple to use with SwiftUI. So yeah, like I'm impressed. That's a very cool thing to do. Let's quickly search for the Metal Builder package because I want to encourage when somebody builds something like this. Okay, so it's already hard to find, at least for me. Metal Builder, metal sample code. Okay. All right. I can't seem to find it. Maybe he linked it. Did he link it somewhere? Probably didn't. But yeah, we'll find it. It's okay. It's a description of this package. So yeah, not really helpful. At least the README of the package. Yeah. So if you see this, please send it because I want to definitely have a look at this.
I'll try to find it after this. Yeah.
I should be able to find it here because here's the GitHub link, right?
Yeah.
It's on his GitHub, right? So that's probably a good place to look. Hello, Metal Builder. Nice.
Oh, yeah.
Yeah, so it's here. I mean, we can have a look at the code inside of the app. So we should probably jump over there, right?
Cool.
But yeah,
Yeah.
if you want to build something with metal, you should probably check this out. It's really cool. All right, so let's make this a little bit more visible. So we have the content view that probably does a lot. We will show this.
So another fun and interesting solution.
Yeah, hopefully. Oh, nice. We have parameters to play around with. It's nice. Let's make this bigger. Ooh.
Just
Nice.
drag, yeah.
Okay, so I want to go full on with the blur. Oh, nice. Oh, this looks so cool, Amos.
Yeah.
Nice.
I like it.
This. Let's make it smaller. Like this is already great, right? So it invites you to play around with it, which is always a great thing, right? Like it's just fun to. Okay, that's a little bit too bright, but let's add some friction. Nice. Yeah, like it's really cool. Like it's already very cool that you can just play around with and create these nice effects. I'm already sold. So yeah, right. It's nice that you're in the chat as well. So yeah, it's cool that you work on this. We're impressed already, but yeah, let's have a look because like it's always cool if it makes it more easy to play around with metal then. All right, we already see metal builder is imported. Nice. All right, so we're probably going to see a lot of matrices here. Nice. Or vectors. Okay, so let's try to understand what's going on. Okay, we have the content view with different states. Okay, that makes sense. We have the metal builder view, right? That does basically a lot of the magic. We will have a look at this in a second. We have the drag gesture that allows to do this, right? And then we have the different settings here. I don't think the settings are too important, right? Because it's basic SwiftUI, right? So yeah, like let's have a look at what the code does. Okay, so we have the metal builder view, and I assume that's something that you created, right? In your metal builder package. So it's a UI presentable, so it's wrapping metal kit. Nice. Is metal kit, is it like the Apple one? It is, right? Please correct me. Roman, I'm not sure how to pronounce it. Roman. Okay, thanks. All right, yeah, so it's the metal builder view. Okay, so we hand down metal functions to it. And metal functions is defined where? Where is this defined? Oh, it's over here. Oh, wow, that's impressive. I won't understand what's going on there. I can already say that. All right, but that's just writing shaders,
a lot of
right?
math.
Yeah, a lot of math. That's what I understand at least.
Cool.
All right. But yeah, it's adding different vertices, different fragment shaders. I mean, yeah, like you can come to Roman's TED Talk to follow along with that code, but I won't go through it because I just don't understand what's going on. All right, we also have helpers here to create some either the circle or the trapezoid. Again, like very hard to pronounce. It's minus points. But yeah, like it's probably just drawing the either circle or this shape. Okay, so what you do is you hand the metal builder view the metal functions. So these are probably the functions that are used to build different elements then. And then with the CPU compute, if dragging a value, like if there's a dragging going on, the scaling factor is 2. So it's probably just scaling this dragging thing up by 2. And then it spawns the particles. All right. So what's the, I mean, you're in the chat, right? So you can you at least say what the difference between the CPU compute and the regular compute one is? That would be interesting. And what the blit buffer, okay, I mean, I have too many questions. I could already see that, right? But yeah, basically it's just computing different, like it's drawing different shapes at different offsets, right? But yeah, does it only look like they're somehow connected, or is that just like a nicely drawn effect? Because like it looks like the different elements on the screen are somehow connected, right? So it would be interested if that's just like an elegant way of drawing it, or if this is really like is that these are really somehow connected through some shader magic. That would be interesting to know. And yeah, like some because he just mentioned that like some documentation would be amazing, right?
Yeah.
Like what we can highly recommend, because we use this for some of our open source work, is to use docc, because like what docc gives you, I mean, okay, so he draws dots and blurs them. Nice, yeah. So what docc gives you is a lot of things for free. So if you document your elements in code, so if you, for example, if the blit buffer, right, if you add some nice comment here and some documentation here, like it will automatically create a nice documentation for you that you can not only show in Xcode, but also basically create a static website from this. And this is really like, this really is powerful. So we can highly recommend using that. And if you have questions around that, feel free to reach out, because it's not hard to do it, but yeah, in the beginning it requires some setup. But if that's done, then it can give you really nice results. So yeah, like you should definitely do this. I think it's a great library if it makes metal easier to understand. So yeah, if you are interested in that, then feel free to reach out. We are happy to help with that. But yeah, Amos, do you have anything to add to this? I mean, I would love to be able to explain what's going on more, but yeah, like it's just limitation of basically me understanding things.
Yeah. One thing I learned from this is like if you check the dynamic island animations, like maybe you have the map and also I think the timer. If the timer detach from the island, it creates this liquid or a metaball effect. So here, if you set the blur to really large value, you get that effect. I just try to recreate that, and then I didn't really know how to do that. But if you set the blur very high here, it creates the same liquid effect. Yeah, and then just try to drag around. Yeah, which is really cool. Yeah.
But I know that you can also achieve this in SwiftUI only.
Really?
Because I've seen someone do it.
With blur? Oh, okay.
I'm not sure how, because I'm also interested in how to do it. But yeah,
I
think
checked
it's possible
on some Twitter post, but I didn't really know how to just do that.
Yeah. But yeah, it's a very cool effect.
Yeah, it's nice.
Nice. Good point. Yeah. Yeah, I mean, yeah. Your Roman also said this is probably the same effect. Yeah, like you can, I mean, you can use blur in SwiftUI as well.
Okay.
Right? So yeah, it's probably something similar. And yeah, true. Like Mert points out that SwiftUI has the particle system, right? So especially in, I think, starting iOS 15, it was, right? You can easily use Canvas to draw cool stuff. So
the canvas is
yeah.
good. Yeah.
All right, so this was the last iOS solution. We have one more, and I'll try to get this running. So you have to give me a second, because the last one is by. Let's go back. By Yogi Rai.
I think he has video as well.
And here's a video, and while this plays, you can describe it, and I'll just try to get it done.
So here, I think he said he tried to just create it using Jetpack Compose also. So yeah, from the video, it doesn't really look sharp as the other ones, but I don't know about the solution. So
yeah, true.
Let's see if you can just run it. Do you have it open? Oh yeah.
Yeah, this will only take like 5 minutes.
Oh.
So choose 3. I trust you, Yogi Rai. I trust you. Let's hope you don't mess things up here. Okay. All right. So, I mean, we can already have a look. It's building, and it's Gradle, so it takes like forever. But we can already have a look at the solution, right? So we saw the video, right? We saw the video. It's looking a little bit different than the other ones, but I mean, it's using Jetpack Compose, so that makes sense, right? And I know that that Yogi Rai mentioned that he was actually learning Jetpack Compose just for this one, so really impressive, right?
Wow.
So it's really cool that he's done this, and he only finished it yesterday, so it's also very impressive and very cool. So yeah, let's see. All right. Good. So we have the app and the source, main Java, and we have the main activity here. All right. So for the UI, we have, first of all, the shape. So, all right. I don't understand what's going on there. Let's see, typography, theme. Okay, that's not what we need. Okay, there's weird stuff going on.
Is he also in the chat?
I don't think so.
I don't think.
All right. So I always hate when there's just random things popping up. I mean, I'm bad at Android, so I don't know how to properly handle it. Okay, so a successful build is needed. Yep. Just run it. Because like what Jetpack Compose basically is that it's just a similar thing to SwiftUI, right? Because Android had this old way basically of creating user interfaces with like these resource files that defined your UI as XML files, which was, I mean, fine, right? But they introduced a new way how to do it that was pretty similar to SwiftUI. So yeah, I mean, that's basically what this is, right? So yeah, let's see. So it's using a canvas, right? And we see it working here. So it's using a canvas with a width and the height.
Yeah.
It's using a path. Nice. So it's moving basically the line here to certain values. Nice. So what I'm wondering is like, how does he do the curve, right?
Is it defined somewhere else?
Yeah, it's so basically this is probably only the yellow light one in the background, right? This is only a rectangle because it just needs to be, right? Because you don't see the bottom part of it.
No.
All right, and then there's here there's an arc being drawn, right? And the path is moving. All right, it's moving, so it's drawing the other shape here. So this is like, I mean, we've seen other solutions from Yogirai before that were not using Jetpack Compose, but this is getting closer to the SwiftUI that we're used to, right? Like with this path, and you can just like move to it and draw lines too. So it's getting,
it's quite similar.
Yeah, exactly, right. It's at least something that is very readable and like similar from these perspectives. All right, so basically we have all these shapes and they're drawing, right? I think this one should probably be the small one, right? Because it's just 30, 30, 87. So it's
it should be.
Yeah, and it's also animating the alpha one, the alpha value. All right, so this is very cool. It's a very nice effect here. All right, so then we have the orange one. So this one, right? Which looks great. I mean, it's very nicely drawn. It could be a little bit larger up, right? But I mean, that's just again very
It just started as well. I think it's
very nitpicky. Yeah, it's great. I mean, it looks very good. So I don't wanna argue here too much. All right. So, but what I want to understand here is how the transition works, because like, so this is basically how to draw the shape, right? So this is drawing the shape and the different shapes, right? So it's all right. It looks very good. I want to just understand how the transitions are happening, right? Okay. So we have the scale shape, we have a movement transition, and a visibility transition. All are infinite transitions, so basically they happen over and over again. And then they're animating. So here we have the scale, right? So this is probably for, I'm not sure for which one it is.
But I think he is animating all the scale at once for
okay,
each one of them.
Yeah, that may be the case. You're right. So we have the initial value, we have the target value, and then we have the animation spec. So it's cool. It's something that's different to SwiftUI, right? Because you can like, it's a different way to define animations. So we basically go from the start to the end, which is like a little bit like keyframes, right?
Yeah.
And then we have the spec, like how the animation should take place. So it's infinite repeatable. So it's happening again and again. And the repeat mode is restart. So it starts again. Okay. And the animation is a tween animation with a linear easing. Okay, so the duration in milliseconds. Okay. And then as an easing, it uses a linear easing. All right. So I'm interested. Like, can you also do something like a eats out easing? Does it exist? Looks bad, right?
Maybe they name it differently. Linear easing. Can you just put ease out?
Linear out, slow in easing.
Linear out, slow in easing. I don't know about that.
Linear. Okay, let's what happens if we have easing. Fast out, linear in easing. Yeah, I think that looks differently.
Yeah.
But yeah, like Matt in the chat, he just wrote that like the varieties make this challenges great because we've seen now pure SwiftUI, we've seen Metal, and we have seen Android. And he says it's very mind opening. And yeah, I agree, right? I haven't had a chance to look at Jetpack Compose, so I'm very thankful for Yogirai that you've done this, that you've used Jetpack Compose and took the time to learn it, because now we're exposed to this as well, and we can only learn from that, right? So thanks a lot. I mean, it looks amazing, right? For the first thing that you've done with Jetpack Compose, like it's really great because this is not a simple one, right? I think we've seen from the so we've seen like this challenge had fewer submissions, and part of it is probably because it's just harder to create, right? So everybody who has submitted one and has at least tried to do it, and I mean the results look great. Like, so these are really people that know what they're doing. So like you're part of a very, very skilled group. So respect for that. But yeah, I mean, I'm not sure what else we can discuss around this solution. I just want to see where the animations are applied, because that's something I didn't understand yet. So we have the scale shape transition. So this is this, right? So you basically define a transition as an element or as a function that returns a float value. All right. And then we have the scale transition animation. So where is this then used? All right. So basically you say the path draws a line. So 70 minus this scale transition. All right. Okay. So it's a little bit different. But I mean, it feels like you have it's just not more control, but it's just a different way to animate between different states, right? So in SwiftUI, we give it an initial value. So the state has a value at the beginning, and then we just change the value and say, yeah, with animation. And here you define basically the entire transition in one place, basically, right? So as the target, and then it's the like how to do it, which is also a very nice thing, right? I like this because like you have one point where you define everything, right? And in SwiftUI, it's happening at different places, which is not bad, but it's it's just different, right?
Yeah, it's quite different. With SwiftUI, you just need the initial and the final, and then it will just handle the in between. So here, it's quite different.
Yeah, you can manipulate it by using different easing functions, right? And different animation types, but still, yeah, I think I also like this approach, right? It's keeping everything related to one transition or to one animation, like together in one point or in one function, which is a very nice touch, I feel like.
Yeah, it's making me interested. If I get more time, I will just look through this kind of animations also.
Yeah, true. I mean, it's like if we had more time, there's so much interesting stuff. But yeah, so Yogirai, thanks for submitting this. We're very thankful because you also help us, like Mert mentioned, like opening our minds towards other technologies, and like I'm really impressed with what you came up with. So awesome job there. And yeah, like definitely keep it coming. So yeah, that were all the things we had prepared for today, right? All these submissions. So if you look at those again, like what do you have a favorite one, Amos?
But I think all of them are interesting, like just finding different ways to just solve the same solution. I learned a lot from each one of them, so I think all of them are my favorite. Yeah.
Yes. And like I just want to I wanted to say that that's a very diplomatic answer from you, that you like all of them.
Yeah.
But basically I just wanted to say the same. So yeah, it's impressive. I always like to just follow along with the implementations, because it's always like either a very or at least a slight difference in the approaches that were taken. Oh, and we didn't show ours yet, right? We also have to show our solution, right?
Oh yeah.
But it's not particularly different, I feel like. But yeah, like we said, we really enjoy like doing this, because we get new ideas every time. So yeah, that's just great. So yeah, like this is our final solution. And we already have questions in the chat what the next challenge will be.
Oh yeah, we'll come after this. we
Yeah,
just mentioned that.
you have to wait until next week. Then we will announce this. But we will make a nice announcement video. So
Yeah, true.
let's see if we take you to a nice island. Let's see. But yeah, let's quickly go through our solution. I don't feel like there's very novel things that we did differently or that we added. As you can see, like the content view has like it's just that's the root, right? We have a Z stack that has the color, and then 3 flame views, basically, right? And each of them is just these like the orange and the yellow part with different rotations. Like this is the root one, this one is the animating one, and this is just the background one with a decreased opacity. And as you've seen, we've hard-coded values here. So yeah, like it's not very responsive. It's just like hard-coded to this thing. Here even there's some commented code. But yeah, that's basically it, right? And then with the animation here, this is just the like animating the offset and the opacity here, and it repeats forever. So this is just this part. And then we have the flame view. So for each flame, we basically have 2 flames. So we have the yellow one, which is at the bottom, and then the orange one. And the yellow one is just like scaled down, right? It has some padding, right? So it's just offset a little bit. And then we use we use this while true loop to just like refresh this, and then sleep for 1.0 seconds, 0.1 seconds, and then just call it again, right? So this is how we did the always animating part. I mean, this could be done more elegantly for sure, but this is just like how we came up with this. And then the flame shape, basically, like, I mean, it's that's the cool thing, that parts of it are always similar, right? And this is the flame shape is, yeah, it's like we have the offsets, we have the animatable pair, right? This is how everybody has done it. And then yeah, you see I've like it took quite some time to find the correct pathing here that looked at least okay. So yeah, we also have like some values. We move to a path, then we add an arc, and then move again, add a lot more lines, and then this quad curve, right? So what we're doing is basically we have like we are basically drawing until here, and then like have this quad curve at the top, so that there's no hard cap there, basically. So yeah, and then that's basically all, right? So there's not more files in there. It's just this content view. So yeah, it's I feel like it's a very unspectacular solution because like we're not doing things any differently than you guys have done. So yeah. But we'll also add this to the repository, of course, so that you can have a look at it. I just have to remove the uncommented, like the commented code.
Yeah.
So yeah, but yeah, this was our solution. I feel like we have seen all the concepts before, so we don't have to go through it much more deeply. But yeah, anything else we want to say? So do you have any questions, lead Mert or Roman? If you have any questions, then shoot them at us. But aside from that,
they just want to know about the next challenge. So
yeah,
do you want to say more about it?
Do you want to say more about it, Amos?
You can just give a sneak peek, and then we make the whole video about it.
Yeah, so at least you're on the right track, right? I mean, if you followed Amos and I, we're pretty big fans of the dynamic island thing. It looks really cool. Like, it has very nice touches to it. I think Apple has done a great job of making use of this otherwise wasted space in a very nice way. And like, if you go into more detail about the dynamic island animations, they also look incredible, right? Amos said already that like this timer that just like pops out looks incredible.
Call that, I think, it's just liquid or metaball effect. Yeah, so nice.
Yeah, it looks incredible, and like there's very nice detailed touches to it. So, for example, like if you for example have the timer, right, and you swipe that up and swipe to a certain side, it doesn't animate in from the middle, but it basically like it moves it a little in a little curve and then pops in from a different direction into the dynamic island. So it's like very, very nice and very detailed thing. So it has a lot of very nice touches. So the challenge will definitely include something in that realm. So like if you want to prepare already, then yeah, it's going to be something dynamic island related. And we'll probably make it a little bit more open. So we will probably give you the chance to just get creative and think of nice implementations. I mean, we have the API already. I played around with that. Like it wasn't incredibly stable, at least from what I could tell, or at least the things that I tried with it. Right. So I think like we'll probably give you the entire freedom to play around with, create the SwiftUI, like the dynamic island idea that you want to see, basically, without the limitation of you need to use the API for that. So yeah, like this is probably going to be it. You should definitely check, like follow us to see like what we will come up with for the video, releasing it. This is it. Mert, you asked how have few people been. Yeah, like I had a little bit of issues like at the beginning of the week, but I feel like I'm back up to speed. So I'm feeling better. And you are always feeling great, Amos, right?
Yeah, very great.
Yeah, and Matt, yeah, you mentioned that the Apollo app has a really cute implementation. Yeah, like I've seen this. It looks great. Yeah, Christian Selig, he has a really nice, like basically a pet who's living on the dynamic island, which looks incredible. That's a really cool idea.
I have to check that.
yeah, it's really, really cool. So if you have more nice implementations of nice usages of the dynamic island, please send them my way, because I want to like just see how people use it. And we'll probably create a video around it to see like the best usages of the dynamic island by third-party applications once we see more of it, right? Because people can now play around with it. So yeah, that's what the next challenge will be around. Like we said, follow us to see the exact release video then. But yeah, thanks again for the submissions. I think we don't have anything else, Amos, right?
No, we don't have anything again. So we want to thank you all for just spending a lot of time with us here.
Yeah, it's always fun. Like I really enjoy
Yeah.
seeing all the solutions. It's just fun to see how
Then
people are also
learning from
excited
each
around
one
it.
of them. Yeah.
Yeah, like that's the goal, right? Learn from different ones. Like we love that that we see different ways to implement it, like the Metal implementation, the Android one. That's just great to have. Like it's incredible to see that. We're very happy around that. And like Roman, again, if you want to know like how to use StockC and how to deploy stuff with it, then definitely reach out. You can host this for free, so it's very easy. So reach out, and again, great solutions by everybody, and we're looking forward to the next one, right?
Yeah.
All right. So have great rest of your days, everybody, and we'll see you in the next one.
Okay. Bye-bye.
Bye bye.